Hello everyone, this is the Droplet Generation group that is part of the Microrobotics VIP team run by Dr. Aaron Ota. In this video, I'll be going over what we have done during the 2020 year. This includes both the spring and fall semester. At the beginning of the year, our goal was to create a new master and fabricate new devices for testing. We are also moving lab rooms at this time, so we also need to recreate the testing setup again with minor changes that will help with better testing as shown here. This is the new master that was fabricated. There are 3 droplet generator devices with one merging module in the middle. This master was used for fabricating new devices that will be used during testing. Fabricating devices was done in the cleanroom to ensure that microparticles wouldn't interfere with the devices. To create the devices, we poured a PDMS mixture over the master and got rid of any air bubbles. Then we let it harden overnight in the oven. After hardening, we removed the PDMS from the master and cut it out the devices. We then placed the devices channel side up on clean glass slides and placed them in the plasma chamber. After being in the plasma chamber for a couple minutes, we flipped the devices so it adhered to the glass slide, then are placed in the oven to set. This is just a quick overview of the fabrication process. There are much more steps to creating these devices. For testing, tubes are inserted into the inlet and outlet of the devices, where syringes are then inserted into the tubes with its respective fluids. These fluids are birad oil, cells, and PCR beads. To ensure that these fluids do not leak out, epoxy is used to cover up any leaks. This is a very crucial step because if a device leaks during the testing process, new devices need to be created and fluids could be lost. The syringes are then attached to the pumps that pump its fluids at certain flow rates. The device is then placed under a microscope, which can record what is happening within the device. Before recording begins, we select a frame rate for the recording. This will determine the amount of images are produced at the end. These recordings are then used in the MATLAB code for droplet counts and analysis. Again, this is just a brief overview of the testing process. There are much more steps to ensure a proper testing session. Our MATLAB code was developed by the Embryo Image Analysis Group and are currently working with them to further enhance the code. The MATLAB code is used to automatically count the number of droplets within a certain test video or dataset. We are currently training a neural network with different images that we gather from videos to learn how to detect droplets. For the neural network to detect droplets in different scenarios, we use a variety of videos for it to learn from, such as having different lighting or different positions of the droplet. We then take those images and manually label what is a droplet and what is not. The blue label is considered not a droplet, while the orange label is considered a full droplet. If the droplet is not fully formed, or less than 75% of the droplet is visible, then it will be labeled blue. If 75% or more of the droplet is visible, it will be labeled orange. Then we gather all the images together into a dataset and run the network training code. After network training, we analyze the results to see if the neural network was able to detect all the droplets. So far, the neural network is able to detect the droplet only if there's a single droplet in the image, but still struggles to detect multiple droplets within the same image. Currently, we are trying multiple solutions to this problem, such as using edge detection on the droplets and filtered images. We hope this will help the neural network to figure out where each droplet is in the image. Thanks for watching.